Hello everyone, my name is Menglei Duan. Now I'm going to give a presentation about my course project in 690. This project is in the field of remote sensing and forestry. I entitled it as a machine learning model for Liana's classification based on multi-source UAV-based remote sensing datasets. Okay, let's start. Firstly, let's talk about the Lianas. What are Lianas? Actually, they look like this, as the picture shows. Lianas are structural parasites. They compete resources with host trees, such as sunlight, water, nutrition, and so on. Also, lianas reduce trees growth and increase trees mortality. As a result, liana infestation will reduce carbon uptake. That's around 76% each year. As a major carbon sink, tropical forests store nearly 30% of global terrestrial carbon. But lianas are reducing this number, as I mentioned above. Fortunately, there are some studies prove that selective liana cutting can increase above-ground carbon uptake. That's around 50% each year. Besides, scientific classifying of liana infestations via remote sensing data sites can guide workers to forest stands that are most in need of liana cutting. So the goal of this project is to develop a random forest model to replace traditional methods by manpower to classify liana infestations effectively. This project was carried out in a plot of a tropical dry forest site in Costa Rica. Here, this table summarizes the multi-source UAV-based remote sensing data sets that are used in this course project. They are thermal, RGB, LiDAR data, and a multispectral image with 4 bands. This diagram is showing the key steps of this project. I manually labeled 3 classes, lianas, healthy canopies, and the forest gaps, based on RGB photo, and that will be used as a response variable. Besides, for those metrics extracted from other remote sensing data sites, that will be used as predictor variables. Then developing the random forest classification model, to test and or validate it. Eventually, the developed model will be used to predict liana infestations in the unknown area. Here are remote sensing images or data products derived from remote sensing data. They are canopy model, multispectral image with 4 bands, thermal image, and NDVI map. 7 predictor variables or 7 metrics are extracted based on this. I put all information in this data table that shows predictor variables are the 7. The class is used as response variable. And each row is for one individual training pixel. So that's around 120 or 130 pixels for each class, like this. This diagram shows how to manually label lianas, healthy canopies, or forest gaps. Furthermore, I divide the plot into 2 parts. In terms of the red one, all training pixels are labeled there, to train the model. Then, using the developed model to predict the left part, that is an unknown area. Finally, to compare the prediction with the result by visual interpretation. Here is the developed random forest model, and it was first validated by a confusion matrix, which shows an accuracy of around 86%. Besides, the analysis of variable importance shows that temperature, near infrared, height, green, and image wideband contribute most for the model. Here is the final prediction result. Now we can see that the model works, although some misclassifications exist in some areas, such as middle left, that canopy was classified as gaps, and some borders of gaps and canopies are misclassified as well. I mean, the prediction by the model can still tell us how many liana infestations exist and where severe liana infestations occur. Then people can decide if it's needed to do something to protect forest, such as selective liana cutting. Although the model can't predict all classes perfectly, I would say those minor misclassifications and bias in some way won't have a huge effect on the liana cutting decision making. That's all about it. Thank you.